Pollution. What pops into your head when you hear that word? You probably think about litter, huge factories, smog, green water, things that are easily visible. But what about the stuff you can't see? This lake might not look obviously polluted, but tiny particles such as trace metals can cause even more harm in the long run than big visible pollutants. So where do these trace metals come from, and how do they get into the environment? Industrial activity, agriculture, vehicular traffic, wastewater, and other human activities can lead to exposure of trace metals into the environment. For example, zinc is a trace metal used in fertilizers and pesticides that can get into the environment through agricultural runoff. You might find heightened lead concentrations in big cities due to emissions from vehicular traffic. Release of these kinds of trace metals can lead to accumulation of toxins in soils, flora, and fauna, and disrupt the homeostasis of an entire ecosystem. Not only can this hurt biodiversity, but it can be a threat to human health as well. Biomagnification of mercury up the food chain leads to poisoning in humans. Other toxic trace metals, including cadmium, lead, chromium, and nickel, can cause renal diseases, cardiovascular diseases, and even cancers. Because of the constantly flowing nature of rivers, it can be hard to get an accurate measurement of the trace metals exposed to the organisms residing in an area. However, some plants with a high tolerance of trace metals can be used as an indicator of long-term exposure to pollutants. The broadleaf cattail, or Typha latifolia, has a high tolerance for heavy metals and therefore can be used as a gauge for the intensity of exposure to certain metals. The broadleaf cattail is a widely distributed perennial wetland plant found in a variety of climates. It can grow almost anywhere that has a constant supply of fresh water. You can often spot them growing near ditches and lakes. They're recognizable by their characteristic cattail structure shown here, which actually serves as the plant's female flower. During pollination, the cattail will sprout fluffy hairs to catch the wind, leaving behind the smooth brown cylinder for the remainder of the year. Broadleaf cattails can grow up to 10 feet high, with leaf blades 3 to 4 centimeters wide. Cattails can accumulate heavy metals in their leaves, but the highest concentration of most metals can be found in their roots or rhizomes. The rhizome is an important feature of the broadleaf cattail. It is a modified underground stem, much thicker than the roots. Through the rhizomes, the plant is able to expand existing sites. In northern climates, the rhizome allows the cattail to go dormant and regrow after winter. As you can see from this graph, concentrations of chromium were consistently higher in the roots, shown in dark purple, than the water, shown as a black line. Measuring water directly for concentrations of a pollutant is inconsistent due to changes on a daily basis from the source of the pollutant. Testing tissue from a bioindicator, such as the broadleaf cattail, however, can give a better overview for the amount of pollutant in a given area over time. Root cell walls initially bind metal ions from the soil and use specialized transporters to move the ions across the plasma membrane. Once inside the cytosol, metals are transported and accumulated in vacuoles.